Good evening. I'm just going to check my sound. A little bit late starting. Technical difficulties. So let's just YouTube. Yep, I'll just go to my YouTube channel and just check how we're going. How our live's going. Just checking for sound. All right. So what's our sound looking like? Have we got any sound at this point in time? I'll just go to my YouTube channel and just check how we're going. Okay. How our live's going. Looks like we have some sound. So that's all good. We'll just fill in the chat here. So, hello. What's the sound looking like? All right. Enter. Have we got any sound? There we go. So here we are, Maths IRL. Now, last night it had a bit of a glitch and things did not go that's all good. We'll just according to plan. So, and we stopped streaming at a particular point. I think we were about to solve this problem here last night. So and I'll go over that and yeah, we'll just work with that. So stopped streaming at a we'll just do a new page here and we'll lock that. I think we were about to so that seems to be already, and I'm just going to grab my S pen and I'll go over that. And yes, we'll just now. So I think it was. Let me. I might have to go back. Page here and we'll lock. I think we're about to. So that seems to be x plus y equals 12. That was one equation. Yes. And the other equation, I think it was to go back. Here. X plus y equals 12. And the other equation was x minus y equals 4. That was one equation. Just like there. And the other equation was x minus y equals 4. That was the second equation. So these are two linear equations that we determined were x, suitable for minus y equals 4 using the elimination method of finding them. And yeah, we use ChatGPT to do that. Okay. Yeah, that's the first equation. All right. Now, so what I did was, these are perfectly as I said. So what we do is we add, we can add equation 1 plus equation 2. One plus 2. And yeah, we can do that. Now, if we add x plus x, 2x, plus y plus negative y, the y's are eliminated. And 12 plus 4 is 16. And we get 2x equals 16. So Going back to previous linear work, divide by 2. Both sides, of course. I've typically put that in square brackets. And divide by 2. And we get x equals 8. So when x equals 8, we can look at equation 1, or we can look at equation 1, and when x equals 8, we can say 8 plus y. So what we did there is substituted into equation 1. So we get 8 plus y equals 12, and then we can subtract 8, and we get y equals 4. Therefore, intersection point is x is 8, y is 4. So that's a point on both lines. Now, what I did was okay. Okay, so what I said is okay. Oh, this is the pair. These are perfectly set, and give it a go. And then I said we calculate that they meet at the point 8, 4, and we'll see if that's good enough, what you say. And so we put that, and they've checked it, and that's the perfect solution. So as I say, I missed all this. Well, I did this last night, but I wasn't recording or streaming, so we're a bit unfortunate. So yeah, that's where we got. So then I said, okay, would like to stay. Oh, right. Well, I said I'd like to stay with the elimination method for a while we have a slightly harder elimination type problem where the x and y variables have coefficients. We'll come back to that because I'd like to do a little bit more with this just to see how it all pans out. So I'll just come here to remind me what the graphs are. So what I did was I drew the graphs. So the first graph is x plus y equals 12, and we can see that if we want to put that in the form y equals mx plus c, we get y equals 12 minus x, or negative x plus 12. So the y-intercept, which is equal to c, is 12, and m, the gradient, is negative 1. So if we draw this graph here, like so, we can say that the y-intercept is going to be 12. So let's say that's 12 there. Now it's got a negative gradient, so it's decreasing. So the x-intercept is going to be negative 12 because the gradient is negative 1. So the graph is going to look like that. It's quite easy to do when the gradient is 1 because we know that these will be equal. However, we can test that out a little bit more. I'll just come down here. We can say there when I haven't got to turn my lock on. When y equals 0, just to confirm this x1, you'll see that you get x plus 0 equals 12. And x equals 12. So that was quite simple. So that there is the graph y equals x plus y. My mistake. That there's the graph y equals negative x plus 12. Also x plus y equals 12. So they're the same graph there. Okay, now the next graph that we are going to do is, I'll do that one here, and it was x minus y. Okay, and if we put that in the form y equals mx plus c, I'm going to put the y over there, put the 4 over there, and then I'm going to flip them around. Okay, so we're going to get y equals x minus 4. Okay, the y will go over there positive, and then the negative x minus 4. So that's the graph, and there we can see that the y-intercept is negative 4, which is down here. And that's when x equals 0, y equals negative 4. We can quite easily see that. And when y equals 0, x equals 4. Oh, I've drawn them a little bit out of scale. That would be 4 there. So I'm going to I know I'm only sketching, but so that would be negative 4 before. Okay, so we can draw this graph coming through there like that. So that's x minus y equals 4, and or y equals x minus 4. And then we can see here that you can see that there's, I've drawn it pretty much to scale. So that there, that's not negative 12, that's 12. 12. Y-intercept's 12, and yeah, 12. Okay, and then this one here, you can see that that's going to be approximately 4, and that's going to be 8, and that's going to be the 0.84, as we said. Now, it's not necessary to draw the graphs and all that. I've just drawn those just to show, you know, and to reinforce how this all works. Because, yeah, we could have, the actual question probably stopped here when we got 8.4. But this here is just by way of explanation and to reinforce how the point is the intersection of two lines. And it's important that we understand that going forward. I think that it's quite key that we don't just randomly get to equations of straight lines and find out where they intersect. There's always a reason for it. And quite often the reason for it, I mean, this might be a graph of, say, something, you know, the cost of ice creams, and this might be the, you know, the number of people on a beach or something. I don't know. It can be the intersection of two quantities, or that perfect point, or, you know, it might be a thing in where two boundaries meet in surveyor, as for a surveyor. There's always a reason for these calculations. We don't just do them for fun. Sometimes the real world application is so complex to explain that we only deal in the simple side of it, whereas in fact there's many factors involved, which is very hard to replicate at the skill level of some of the learners sometimes. So, but yeah, two lines where they intersect here. So moving on from there, what I wanted to do next was do another one, but this time one where we had coefficients. All right, so this one here, we'll just add another page, and this is another one here. Okay, so let's have a look at this one. We've got 3x plus 2y equals 26, and 2x minus 2y equals 4. Okay, now, so the simultaneous equation, what we'll do is add 1 plus 2. Now the reason why we're adding 1 plus 2 is because it will eliminate the y's, because one's plus 2y and one's minus 2y. So yeah, add 1 plus 2. So that's the equations. And so put a line under. That's going to be 5x equals 30. And then we'll divide by 5. X equals 6. Okay, when x equals 6. 3 times 6 x plus 2y equals 26. That's equation 1. So that's 18 plus 2y equals 26. We'll subtract 18 and we get 2y equals 26 minus 18. 2y equals 8. Divide by 2. Y equals 4. Okay. The point of intersection is 6, 4. Okay, so that's where the two lines meet. They're both linear equations. Okay, which we've identified them as linear equations because the power of the x is 1. Okay, power of the x is 1. That's how we identify linear equations. I may not have mentioned that previously, but yeah, the power of the x is 1. Okay, now let's just do a check. So we'll substitute in 1. So 3 times 6 plus 2 times 4 equals 26. 18 plus 8 equals 26. That's all good. And we'll substitute in 2. We get 2 times 6 minus 2 times 4 equals 4. 2 6s are 12 minus 8 equals 4. So we can be pretty sure that we've got it right. Okay, but let's just see what we've got here, how we're going. Right, and okay, we got bracket. What did I say? 6, comma 4. Close the bracket. Yeah, that's what we got. So let's see how we went. Bang on! You absolutely crushed it. That was a great example of how coefficients don't have to make elimination messy. Just takes a smart eye like yours. Want one next where you have to scale both equations first? Well, we do, but in this one here, we're going to, we'll just have a look and see how the straight line things work, I think, and then we'll leave that remaining one for overnight. So first graph was 3x plus 2y equals 26. Okay, so let's minus 3x. Minus 3x. Okay, so that gives us 2y equals negative 3x plus 26. Okay, there, and then divide by 2, and that'll give us 2 there, and so that will give us y equals negative 3 over 2x plus 13. All right, let's draw that and try and get that to scale here. Okay, so our y-intercept is 13, so it's up here. I'll say that's about 13 there. Our gradient's negative, and it's 3 over 2. So let's just try down here. When y equals 0, we can see when x equals 0, y equals 13. That's pretty easy. When y equals 0, we get negative 3 over 2x plus 13 equals 0. So we get 3 over 2x equals 13. I just added 3 over 2x to both sides. And then we've actually, well, we'll multiply by 2. I'll do this in 2 bits just to make it simple. So we get 3x equals 26. And then we divide by 3. And we're going to get x equals 3/8 of 24 and 2/3. 8 and 2/3. So that's 13. There's roughly. So that'll be 8 and 2/3. And we can see, we know the graph is negative. So there's that's 3x plus 2y equals 26. Okay. Or y equals negative 3 over 2x. Right. So let's have a look at the next one now, which was 2x minus 2y equals 4. Okay, 2x minus 2y equals 4. I'm going to add 2y, and we'll get 2x equals 4 plus 2y. Well, minus 4. We get 2x minus 4. Oops. 2x minus 4 equals 2y. So then we'll divide through by 2. And we get y equals x minus 2. Y equals x minus 2. We can see that the y-intercept will be -2. It's a positive. Let's just tidy a bit there. 13, 2. So that's our x-intercept there. Our y-intercept, that's our y-intercept. Our x-intercept will also be 2 because the gradient's 1. It's a positive gradient, so that's 2, 2. So it's going to go somewhere up there like that. Okay, and this is going to be our point of intersection here, which we determined was what did we say it was? Oh dear, what's it? 6, 4. 6, 4. So, yeah, I think we can see this is going to be 6 here approximately. And, yeah, that's around about 4. 6, 4. So, again, we can see how it works by drawing the graphs. We can see how we determine the x's. I think it's sort of all very helpful information. So that's done us for half an hour now. We are still streaming. Fortunately, nobody's asked any questions or anything like that. Probably because there's nobody in the live. But yes, there it is. So let's go and have one more for tomorrow night, which we'll look at tomorrow. Want the next one to have scale. So let's go yes, please. And there we go. And ChatGPT will, here's a level up elimination. Now, this is the next one, which I want you to see if you can do this one. But what you'll see here is you get 2x plus 3y equals 31. 3x minus 2y equals 4. And you'll see that's a little bit different because these are not the same. If you add them, you won't eliminate anything. So you've got a little something that we've got to do there to make it so that if we do add them or subtract if you want to, you can actually subtract them too, that you'll eliminate the values and go on from there. So that's something for you for tomorrow or the next session, session 10. Hopefully it'll be tomorrow, but maybe not. Who knows? Anyway, there you go. So that's it. Maurieo Maths IRL, a little often is the secret to success. So yeah, good night. This has been a Maurieo presentation recorded live in our lovely little studio in downtown Ngaruawahia. The Big Smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. Good night and good gardening to you all.